Hey everyone, welcome to Tiffany Talks Telemetry. I'm your host, Tiffany. As a solutions consultant here with Harris in the Twin Cities, it's my job to help building owners and managers operate their facility as efficiently as possible. And over the years, the way we monitor and maintain buildings has changed, so I'm here to share the exciting news around it. Stay tuned and get ready for a new episode of Tiffany Talks Telemetry. Welcome to episode 2 of Tiffany Talks Telemetry. Today, our guests are Cole Mason and Ben VanderSluis. Cole has been with Harris for almost 9 years as a service supervisor. He's an experienced pipe fitter with the St. Paul Local 455. He has been with the telemetry team since inception as a telemetry champion. Ben VanderSluis is the Director of Data-Driven Solutions at Harris, and he's been with the company for 3 years. He holds a PhD in computer science from the University of Minnesota. At Harris, he works on our telemetry platform, applying his skills to wrangle a vast amount of building system data and determine how Harris can best use it to deliver a higher standard of service to its customers. Hey everyone, welcome to today's podcast. I'd like to start this one off by kind of jumping right in and asking you both how to explain the telemetry process, the setup process, and some of the challenges with inconsistent data.
We support, nearly 20 different control system or building automation system makes and manufacturers. Things vary from site to site to site, and what we need to do in order to determine what's wrong with a building is we need to get there and we need to determine what everything means. So, and sometimes there are things lying around, so I came into work today and I normally work from home and I noticed I've got some expense codes up on my cube, and they're from 2 years ago. So if someone were to come sit in my cube and fill out an expense report using those codes, it would be be mostly right, but it wouldn't be correct. It wouldn't make any sense. And we have sort of the same struggles. When we get inside a building automation system, we're trying to figure out what everything means. There's leftover stuff. There's points that don't mean anything or aren't used anymore, or were copied and pasted from somewhere else. And we often don't have a lot of documentation on what everything means. So we have to kind of get in there and figure out. So we make our best guess as to what everything means. So sometimes a room like this will have 2 different temperatures it's trying to reach. The system's only really trying to reach one of them, and we don't know which one it's paying attention to. Mm-hmm. So we'll have to put in our best guess, and we make a note of the things we don't understand, and then somebody like Cole, who knows the building better, will get in there and help us figure out which thing is the true thing.
Mm-hmm. Cole, could you tell us a little bit about the setup process with telemetry?
Yeah, so we go in and install the agent. It's just a small little device that we connect to the automation network, and then verify that it's communicating, and then Ben and his team pull all that data in and set up all the rules for the monitoring. And then from there, it just kind of takes off, mm-hmm. and then deal with all the issues after that.
Is it a relatively easy process to get it all installed and set up?
Yeah, it's just plug the agent into a nearby outlet and then Ethernet cable from the agent to the network, and that's pretty much it.
So Ben, could you talk a little bit more about what a building score is and how does it differ from traditional alerts and alarms?
The point of a building score is to sort of roll up all the problems into one easy to understand number that you can track over time. So an alert will say, you'll have an alert that says, okay, the rooftop unit is off, and that's an alert. And that has it's like a one-time event. Or you'll have an alarm that says, oh, I tried to turn the building automation system will say, I tried to turn this pump on and it's not telling me that it came on like it's supposed to. That's an alert. That's a one-time event. And when you start to get a lot of these, they just typically what happens is they kind of pile up on an alert screen that maybe somebody's paying attention to, or maybe they're not. And they're really good for one-time serious events. If you need to know that something went wrong right now, that's and you're going to handle them as they come up, that's a pretty good model. You want to get somebody, you want to get Cole to look at that pump right away to figure out what the problem is. But they're not great at things which are less important over longer periods of time. So, for example, if this room is always 4 degrees too cold for 3 months out of the year, first of all, nobody's going to write an alert like that. And second of all, when it comes up, nobody's going to care, right? You have to have like a long-term view in order to sort of think about things and address those types of issues. So what a building score does is we have lots of rules that are the same type of rules you would have an alert, but or they work kind of the same way. But we would write some that you would never write an alert for, or typically that we don't have time to write an alert for, like it's 4 degrees too cold in this room. There's not typically an alert on the system for something like that. Sometimes there is. And the other thing that it does is it captures the severity of each of those things, right? So when a pump doesn't come on when it's supposed to, that's a big deal. If the pump is on when I didn't tell it to come on, that's less of a big deal. Probably somebody who knows what they're doing turned it on. So we want to capture like how severe are each of these things, and we want to capture like how many things are wrong with the building, and we want to capture like how long. So like so maybe it's 4 degrees too cold in this room, but only for an hour in the morning. Well, that's not as big a deal. So we need a way, so if you had an alert that said it's 4 degrees too cold in this room, that would show on your screen, and then by the time you check it, it's gone and sort of worked itself out, or it's not a big deal. So we want something that how the scoring works is each of these rules, instead of generating an alert, some of them generate alerts, but most of them will ding a piece of equipment on its score. So the score starts at 100, and if it's too cold in here for an hour, it'll lose 15 points, but just for that hour. And then if the score over the entire day is still like 99, then you've probably got bigger fish to fry. So it's a way to kind of take all of these little specific rules about the specific expectations we have on each piece of equipment and roll them up into one number to say, answer bigger questions like, how is my building doing? Or how is my building doing compared to last year? Or how is my building doing compared to, the building next door?
Mm-hmm. So how are we getting from that data to physical action? Cool.
So I have a monthly review for all the sites in St. Paul. So it automatically generates like an open issue list on a spreadsheet. So every month I review those issues. And while I'm looking at that issue list, I am also connected to the customer's automation system. So I can look at the issue and look at that piece of equipment in its current state and try to figure out if there's an actual issue, if it's, maybe an isolated incident. And if I feel like it is a valid issue and needs to be taken care of, then I contact the PSRs and the dispatcher, and then they can present that to the customer for somebody to go on site and look into the issue and correct it.
Okay. What are some of the typical things that you see when you're reviewing these buildings?
I'd say mostly a lot of occupancy schedule issues, a lot of temperatures away from set point, that kind of stuff.
Yeah, no, I mean, one of the major things that we're trying to do is save energy. And the easiest low-hanging fruit for energy savings is this occupancy. Is that somebody gets one complaint from one part of the building, and then they decide to address that complaint. They just turn everything on 24/7, 365, right? And then the bill goes up by $10,000 a month or something. So that's been a real early focus. But otherwise, some of the things that we're looking for, I don't know that this one has come up recently in St. Paul, but most buildings have like an outdoor air temperature, a sensor somewhere in the building. And sometimes it's not working, or sometimes it's put in a bad spot. And so one we found recently was this sensor didn't agree with the local weather station by more than, I don't remember what the rule is. It was off by like 10 degrees or something, which means it's in the shadow, or the sensor has failed or something. Mm-hmm. And the building could be making lots of decisions based on that one outdoor air sensor. And that's another thing that, you don't typically bother to to write that kind of rule in a building automation system. But it's something that we can afford to do because that's very easy for us to sort of implement everywhere.
Mm-hmm.
And in that example, that outdoor sensor would be sharing that temperature to all the rooftop units, we'll say. And it's using that temperature to determine whether we're going to mechanically cool with compressors or free cool with the economizers.
Mm-hmm.
Right. So if it thinks it's nice and cool outside, but it's actually kind of warm, then you'd be wasting a lot of energy. You'd still be comfortable in the building, right? Because the system would probably be able to overcome it.
Right.
But
there'd be a time where if it was free cooling when it shouldn't be, and it wasn't able to satisfy, then it would more than likely kick on mechanical cooling with the compressors.
Right.
And eventually satisfy. It just would take some time.
Gotcha. So one of the big questions that I always get asked when I'm out in the field is, how does telemetry differ from their current automation system? So what's the simplest way that you would explain that to a customer?
Well, the automation system is responsible for making the building comfortable, but it's very short term in its thinking. It's trying to make the building more comfortable on a minute by minute basis. And it's also robust. It's also designed to overcome issues that you might not want to ignore. So if you're, like in this example, if you're bringing in outside air when you shouldn't be, and maybe it's not because of the sensor, maybe it's because the outside air damper is stuck open or something. Well, the building automation system says, okay, it's my responsibility to put such and such a temperature in this duct, and it will do it by hell or high water. It's not responsible for long-term energy savings, or it's not responsible for long-term improvement. As a result, it's not looking for things like, if this room is too cold by 4 degrees, it's going to do everything it can to bring it up. But if it can't bring it up, you're going to have to wait till you get a complaint probably from an occupant. Mm-hmm. Or somebody will put a space heater under their desk or something. We see that a lot too. It's just tries to get at this sort of higher level of expectations and sort of longer term. How do we notice? We want to notice small problems before they become big problems, right? You're only going to have an alarm when a problem is important. Otherwise, you have 5,000 alarms you have to look through every day. Mm-hmm. And you just want to kind of summarize. I mean, the building automation system is great for when you know there's a problem, drilling into it and figuring out what is wrong, mm-hmm. or changing how the system operates. But it's just not as good at answering the higher level questions of like, how is my building doing? Or like, what is so I can ask Cole, what is the biggest problem in a building? And, he knows the building, most of the buildings, he knows inside out, and he's got his sense of what the biggest problems are. But we want to be able to answer those questions in a way that I can show something to Cole on a building he doesn't know inside out, but he knows, he's got a lot of experience. He knows what problems are common. So we want to be able to show him, some preliminary report and then get his input on what's a big deal. Mm-hmm. And the other thing is the building automation system, the data is usually stuck inside the building, right? So we name this telemetry because, the biggest, hardest part of this, like I said, we've got 15 or 20 different makes and manufacturers out there as a service company that we're trying to help and improve on this platform already. And the biggest challenge is just to get it out of the building, right? Mm-hmm. So that we can do something with it and make it all kind of look the same so that we can have kind of a standard process. Right. And that's our goal. If we can get it out of the building and then get the experts at Harris to have a look at it, right, without having to roll a truck, then that's something that a traditional building automation system is just not very good at. It's just too narrow in its focus, and rightly so. That's its job is to make it comfortable. Yeah. But it's Harris's job to make the building more comfortable over time.
So speaking of expertise in the field, with less people coming into the skilled field, and there's obviously an increase in the demand for the services, what does that mean for telemetry? How does that fit into the solution for the customer?
Yeah, one of the things we were hoping is this would save us on labor that we could get. It would take less. It would take fewer technicians. The reality is, we find a lot of problems, right, with buildings that even people think are performing pretty well. So, I mean, the nice thing is when Cole does his reviews, you do them from here in the office.
Yep.
Yeah. So, I mean, he can log in remotely, and he can. So that saves him a trip, and so he can do a bunch of buildings back to back to back with less time on the road. The hope is that when we do send somebody out, that they have a head start on what the problem is, right? They know right where to go, right where to look. Or when they're going out to do something like change filters or something, hopefully they can look at one or two extra things on the list.
Yeah.
And again, without making a special trip, but yeah, it's a different level of that constant monitoring that Cole talked about. Kind of exposes, like, it kind of sets a different standard. Yeah, the hope is that we could stretch the workforce further, but we find I think we're finding more work than we're saving.
The goal is to detect, issues before they become major issues. There's a lot more issues to be looked into.
Yeah.
And it's very difficult to determine whether it was an isolated incident, if there was an external factor that, caused that issue to generate. Could be something as simple as the building maintenance person got a noise complaint, and he went up to the roof and turned the rooftop off for 20 minutes while he looked at stuff, turned it on, while it generated an issue between that time, or the time that the unit was off. Stuff like that. It requires more investigating and to figure out if, it's an issue, if it's going to be an issue, all that stuff. It just is very challenging.
Yeah.
Instead of just dealing with the major
Right.
issues, which would be, the point where the customer or the building occupants notice it and then put in a complaint.
Any success stories that stand out in your mind, or anything that you've come across where you figured something out and just really stands out to you?
Like I said, there's a lot of them that are pretty simple. So I was with a technician, actually. This was in the Pacific Northwest, and the unit that served her office had just broke, and the damper didn't work, so it wasn't opening up to provide her with. I think it had reheat, and it wasn't able to heat the room up, because she wasn't getting any airflow. And she had this was in the wintertime, and she had just started wearing sweaters to work, and she was not the type to complain, right? So this is the type of thing that it's a simple fix. It took, I think, we weren't able to fix it that day because he had to order an actuator or something. But that's the kind of thing that, if she doesn't complain, it's 2 years before somebody notices that and fixes it. Or she brings a space heater in or something. Yeah. And those little things, they pile up over time. I mean, that's the buildings will just, buildings are big, complicated systems, and they will just slowly degrade over time. As an industry, we're very good, when the chiller fails, we're very good at responding to that. Mm-hmm. But these little things pile up, and we basically wait for it to get really bad, and we try to replace the whole system or something. It's very difficult to keep track of. And like Cole said, if you're trying to keep track of things that might become serious issues in the future, we end up just keeping tons of things on the radar. And we just try to keep it like in a holding pattern, and we're watching it, and we spent a little bit of time investigating it. But our technician got this thing fixed eventually, and that was great. She could tell the facility guy, and the facility guy could brag to his boss that they had gotten ahead of a complaint, Yeah, it can be tough when we're used to kind of swooping in and saving the day when things break down, right? And when you fix a problem the customer doesn't know that they have, you don't always get a pat on the back for it. So right. we have work to do in communicating some of those successes that were, we fixed a sensor, and okay, it wasn't a big success because nothing failed because that sensor was bad, but it would have. Some of these things are not flashy, right? The preventative stuff is not flashy, but it's economical, and that's our job to save the customer money in the long run.
Yeah.
Actually, there's a church on the East Coast where we had some alerts set up. This was early in the pandemic, so they have an on-site facility guy, and he was working from home. And I think I don't remember what his schedule was. He would check in on Saturday or something. They had services on Sunday. But, the equipment broke down, and, it's not something he would have noticed probably for 4 days because he's working from home.
Right.
And, if some of these old churches and stuff, if the humidity gets all out of whack, then, the organ is ruined, or they have to, they've got art and a lot of wood and stuff, and it's not good if the climate controls in the buildings break down. It's something you need to notice right away. So we got our local technician there out to fix it, and while we went out to address this emergency, and he just had to reset the chiller. I think the chiller went into alarm, and they put in this energy saving measure while he was out there. So that's a case where he, we saved a trip, and they actually came out of that emergency better than they went in, because not only was the chiller working again, but it wasn't using so much energy. So that's one we like to share.
Yeah, it's a good success story.
I mean, to me, that has been the story. Is like fix 2 extra things on a visit, and over the year, you see that you've got fewer spaces that are. Your building is more comfortable. It's not what we're used to doing. We're used to being laser focused on the chiller and this kind of stuff. But
And the big things.
Yeah. In Utah, they have it's a big office building. They've got lots of these VAVs, and a bunch of the VAVs are older, but we know that they fail in this certain way. And so they made a plan. They're just going to replace all of, and that's okay. It's not a terrible plan, but some of them are working fine.
Mm-hmm.
And the customer does not have a lot of money, right? So we have to put them on a long-term improvement plan. With the telemetry scores, it's very quick. You can say, okay, we've got 20 of these on the plan, but which ones should we do next month? Well, these are the 4 that we know can't meet their flow set points. So we should probably not just do all of this brand. We should probably start with these 4. Mm-hmm. And the customer will get the most bang for their buck. It's lots of simple stuff and a cumulative impact over time is the, for me, those have been our biggest successes. And we've had a few big, we had a construction job where at the end of the testing, somebody turned the outside air dampers and just put them all the way open for some commissioning, or they were doing some test routines when they started the building. And then they're finished, they left them open for months. So they were pulling in 100% outside air, and nobody's looking at the energy bill. That was pretty pricey mistake for somebody just set it and forget it.
Yeah.
So we have a couple of big success stories, but mostly it's buildings break down a little bit at a time, slowly over time. Mm-hmm. And what we want to do is have a strategy that does that in reverse.
Yeah.
We want to make the building always, what is the next little thing that we can fix, and always going uphill on that score.
Well, thank you both so much for taking the time to join with me today. Until next time, I'm Tiffany with Tiffany Talks Telemetry.